Hello everyone, my name is JaeHyuk Kwack. I'm working at the Performance Engineering Group in ALCF. I'm going to talk about Cray performance analysis tool as known as CRAYPAT. I will quickly do the overview of the CRAYPAT, and then I will introduce the two modes to use the CRAYPAT-LITE mode and in-depth analysis. And then I will show you how to use the performance counter through the CRAYPAT and CRAYPAT API and Cray Apprentice tool for the GUI analysis. Okay, CRAYPAT is for whole program performance analysis with novice and advanced user interfaces. It supports for MPI and SHMAM and OpenMP and UPC and CAF and also accelerator on other systems. You can get the load imbalance detection, and you can also read the hardware performance counter metric, for example, hit rate or computation intensity for roofline analysis, etc. And you can also get some observations and inefficiency from the CRAYPAT report, and you can also get the data correlation to user source. There are different way to get the performance data. For example, you can get the sampling or tracing with runtime summarization, or sometimes you may need to do the full trace with timeline mode, which is highest overhead, but a lot of information. One of the confusion about CRAYPAT is people think it may work with only Cray compiler, but it's not true. So for the CRAYPAT, you can use a Cray compiler, which is CCE, or you can use Intel compiler and GCC compiler on Theta. On another system, you can also use a PGI compiler or ARM compiler for this profiling. And again, the Apprentice tool provide a visual interface to performance data. Okay, again, so the CRAYPAT provide the two modes to use. CRAYPAT-LITE is for usually novice users or some conveniency. And CRAYPAT provide the full functionality for the in-depth performance investigation and tuning assistance. Both of them offer the whole program analysis across many nodes and also provide indication of cause of the problems and also provide the suggestions of the modification for performance improvement. So let me introduce how to use LITE mode, which is the most convenient way to use. For LITE mode, first of all, you need to update your modules. Darshan module has a conflict with CRAYPAT, so you need to unload Darshan first. And then you need to load the PerfTools base, which is a common modules for PerfTool-LITE and PerfTool, both of them. After that, you need to load PerfTools-LITE module, which is just for the LITE mode. After that, you can just build your program as usual. Just make, or you may use spec, you may use CMake, whatever you want. You can just build your application. And then you will have your executable binary. In this example, I put as A.OUT. The name looks the same as before, but this executable is actually instrumented program. And then in order to get the performance data, you just need to use this instrumented binary using the apron. So apron and some required flag, and then using the A.OUT. After that, you will get the condensed report to the standard output. And you can also create the RPT file, which is same as standard output. Or you can create the AP2 file for the further analysis using the Apprentice tool. This is the example of the CRAYPAT-LITE output. So as you see, you can see the CRAYPAT version you used, and then number of MPI rank, and number of MPI rank per node, and number of thread per MPI rank, and also you can see the core per socket. So on Theta, we have the 64 core KNL socket, so you always see the 64 core per socket here. And you can also see the execution start time, and also the system name, and the node architecture, the DRAM, MCDRAM, and the memory high watermark, and also the I/O rate, and etc. On table 1, you will see the profile by function name. So in this example, 100% used in total, and 46.6% used by the user subroutine. and 45.5% used by the plus package, and 6.3% by the MPI, and 1.5 by the etc. And then in each section, you will see the additional profile by the kernel names. In table 2, you can see more details for the profile by the groups and functions and the lines. Again, under the user subroutine side, you will see the bsvd.f90 uses 32% of time, and under that you see the percent of time of each lines here. It also provides some information about the MPI efficiency. So in many cases, if you can maximize your on-node communication, and if you minimize inter-node communication, which means you don't actually use, it means you minimize actually network bandwidth, right? Which is, in most cases, bottleneck of the communication. If you do that, you can maximize your performance in many cases. So in this example, CRAYPAT-LITE generates some observations about these features, and then in the output, it provides some point-to-point MPI communication, and also provides some suggestion to reorder the MPI ranks to reduce the inter-node communication. In this example, it predicts 4 different ways, and then it suggests custom rank order could be the best, could provide best performance, because custom rank order generate the maximum on-node MPI communication. So it is highly recommended here. So in this case, CRAYPAT-LITE automatically generates MPICH rank order that can be used for your next execution. So if you use this file for your MPI rank order, you can get higher performance than before. And CRAYPAT-LITE decide work is well balanced or not. So if your work is well balanced, it doesn't generate this information. And also CRAYPAT-LITE provide the memory bandwidth by the NUMA node. Here it provides the traffic and the DDR traffic and NCDRAM traffic and time, also NUMA domain. And also provide the file input and file output information. For example, you can see what is the write rate of each cases. So one of the reason this portion is important is if you use CRAYPAT, you cannot use Darshan because of module conflict. Because of that, this information, even though this information may not be sufficient compared to Darshan, but CRAYPAT also provides some information about your file I/O, so you may catch some issue if you may see some performance data for file I/O from CRAYPAT. The default report, as you see, intended to be useful for the most applications, but sometimes it's not sufficient. In that case, you don't need to rerun the program. You just need to do the post-processing again using PAT report and then get the more extensive data. So for example, if you want to get the fine-grained thread imbalance information for OpenMP program, you may use PAT report with this flag. In this flag, you activate all the performance data from the old MPI rank and all the thread. And then you will have much longer report, but you will see more data. So this is example of the light mode. In many cases, light mode is really good to capture your performance profile. However, in some cases, you may need to go deeper analysis. In that case, you can use the CRAYPAT. CRAYPAT is a superset of CRAYPAT-LITE, so you can get more functionality. This is a simple user guide of how to use the CRAYPAT. Again, you need to update your modules on Node Darshan because of conflict. Then load perf tool space, which is common module for light mode and in-depth mode. And then you need to load the perf tools. And you need to make you need to build your application again with these modules. And after that, you have one additional step, which is for the instrumentation. the reason the additional instrumentation step required with CRAYPAT is CRAYPAT provide many options for your instrumentation. For example, sometimes you may want to do the tracing the MPI functions, or you may want to set up some CRAYPAT API, and you may want to look into some specific region of your code. For this purpose, you may want to instrument your code in different way, because it is why you have to have the instrumentation step. And after that, if you do the instrumentation, you will have one additional executable binary ends with the plus path. So to run your program with profiling, you need to run this instrumented binary with epron. And after that, it generates the report, and you can use the path_report to generate the RPT file and the AP2 file for the further analysis. So path build, this is for instrumentation step, and it doesn't require any special flag. So one confusion between the debugging tool and the profiling tool. Debugging tool require -G because they need to see the large source code. And also, many debugging tools suggest to use -O0 because sometimes the high optimization just remove the capability to trace your variable values, right? But performance tools are different from the debugging tools because of that. That request or that requirement is not required, and so they don't require those recommendation, right? So if you don't want, you don't need to add -G with CRAYPAT. You can still get the performance data. And if you want, you can use the very highest optimization, and then you can get the performance data with that optimization. This is an example of the instrumentation options. Again, the CRAYPAT is a superset of CRAYPAT-LITE, so you can do everything you can do on the CRAYPAT-LITE with CRAYPAT. So if you instrument your code with just path build and your executable binary, you will generate instrumented code with automatic profiling analysis, which is exactly the same as CRAYPAT. And if you want to use some predefined trace groups, you can use the -G trace group and then instrument your code. Or you want to use, you may want to use the CRAYPAT API. In that case, you use -W. And sometimes single function tracing is enough. In that case, you can use the -T and the trace function name. Or if you have a list of functions you want to trace, you generate the trace a file that has for the list of the function, and then you can do the -T, lower score T, and then trace file, and then you can get the data. You can instrument your code. And after everything, you will have the executable binary ends with the plus path. With CRAYPAT, you can choose two different modes, which is the sample mode and trace mode. And sample mode, you can check your program counters and core stack 100 times per second. And you can also adjust the sampling frequency, so you can reduce the overhead and you can increase overhead with more data. And you may want to use a trace mode because in trace mode you can insert the trace. You can have the trace code inserted. And you can also have additional information sometimes, such as MPI messaging size. Or if you use a Cray compiler, you may have additional trace feature, which is loops and loop lengths. Or sometimes if you want to trace a small routine effect one time, sample mode, you may miss that because of sampling frequency. But if you use trace mode, you can trace everything. So because of these two different features, sample mode has lower overhead but limited data, and trace mode has a higher overhead with large data. So our recommendation is use two-step approach. First of all, do the sample mode, and then if you have additional data, you may try the trace mode. And this is predefined trace groups with the -G trace group. So in many applications, the plus is very important, and if you want to see what's going on in plus, you may just use -G plus and then see the more data. and Cray Fortran, HDF5, heaps, and IO, and LAPACK, and MES, and MPI, which is my favorite as well, and the OpenMP, and pthread, HMAM, System IO, and System, and UPC. And this is not the old list. So for example, if your application heavily used Apache, you may have HG Apache. So for more groups, you can see the manual page of the PAT build. It provides all the features. Okay, you can also control the data collection with the runtime options. Usually they start with pat_rt something. So I will show you one example on the next page. So using these runtime options, you can enable the full trace, and you can also change number of data files created. Also enable the collection of CPU and network and power count events. Also trace the filters to control the trace file size. For example, the maximum thread size or max call, stack depth, etc. And again, the Cray support the row counters, so you can use hardware counters for the processor and network and power. So you can use that. For example, the performance counter for the processor, you can use pat_rt_perf_ctr. Using this environmental variable, you can specify which hardware counter you want to get. So on Theta, we have 4 types of the hardware counters. So PAPI counters and the native counters and the drive counters and predefined groups. So PAPI counters, you can use the pat help or PAPI avail on the compute node to see which PAPI counters are available on the KML node. For native counters, you can also use the pat help or PAPI native avail on the compute node. And for drive counters and predefined groups, you can use pat help to see the more information. So my recommendation is to start with one of the predefined groups, because predefined groups include the popular set of the hardware counters group. So just try one of the predefined group, and if you feel you're missing some information, you can add additional counters using from the PAPI counter or native counters or drive counters. And CRAYPAT API. So this is very important because many of you are working on legacy code. Probably your application is older than your career years. So in that case, you don't need to profile the entire application. Instead, you may want to just look into some specific portion of your code. The CRAYPAT API is really useful for this feature. This is to focus on the certain region with the code to reduce your sampling overhead, or reduce the data file size, or just see the particular region of your interest, right? So you need to insert calls in the program source, and then turn data capture on and off at the key point during the program execution. It has the C API and the Fortran API, both of them. And this is and also I use the compiler macro. So if you load the perf2 base, Cray_pat is defined. So if you use this compiler macro, you can implement CRAYPAT API, and then you can use those API only on Cray machine with this module. So if defined Cray_pat, and then I added API, and then this code, you can run with this code. You can run this code on the another system, for example, IBM system, because IBM system doesn't have perf2 space. So this part will be automatically deactivated. Or even on the Cray machine, if you don't want to do the performance profiling, and if you don't load the perf2 space module, this part will be deactivated automatically. So this is a very convenient way to implement CRAYPAT API. This is the essential functions to use the CRAYPAT API in C syntax. So you need to use a pat record with state on and off. And inside of the pat record region, you can set the pat region begin and end using the ID. So you can set the different region with different ID, and then you can see the data differently and independently. So using the path region begin and path region end, you can define the boundaries of the region. And this region can be separated or it can be nested. So depending on your need, right? So in this example, we have some initial process I can ignore and then turn on the path record on. And after that, I have some task of interest and I set the region 1 in here. And then after some task, and then I set another task of interest at the region 2. So after profiling, I will see the region 1 and region 2 independently, and I see what's going on 2 tasks. This is CRAYPAT API example, Fortran. Again, I wrote the header for the Fortran, and then I start I put the record on and record up here, and instead between them, I set the region 1 in here. And this is a C example. Again, using the header, I set the header here. And this is the part of interest. I turn on the record and turn off the record. And inside of this on and off, I see I want to set a different region for depends on the L value. So I set L0 to the region 1, L1, region 2, L2, region 3, and then after that, I will see the 3 different profiling results for the different roof index. Okay, so the last part is Apprentice tool, which is a GUI tool for visualizing and manipulating performance analysis tool captured by during the program execution. First of all, you need to use path report to create the AP2 file from your Excel file, and then use the Cray Apprentice tool to open and explore AP2 files. So you don't need to use the compute node for Apprentice tool. You can just easily use the login node on Theater, and then model on node darshan and load PERFCTR space and PERFCTRs, and then if you run the app tool, you can see this window pop up on your screen. And then if you click the file, and then if you click the AP2 file, you can see the more data. So this example is generated by one of my undergraduate intern, Michael Simon, last year. He was summer intern last summer. He stayed here in 10 weeks. And his mission was measuring the ECP proxy application performance on the Theater, which is Lagos. This is very interesting application, finite element based application. It has arbitrary Lagrange Aurelian framework, so it's really good for capturing the shock wave and also some free structure interaction. It's very, very interesting code. And Simon, he's a very smart student, but he didn't have any experience on HPC simulation or profiling. But I just taught him how to use CRAYPAT, and then this is generated by him. On the overview, you see a lot of interesting chart here. And the profile view, you can see what is this old course or what is sorted by the times here. And you see on time, this application uses MPI all reduced and 3%, and also BCast and 4.7% over time, right? And he did some scaling tests with a different number of nodes and Theater, and he found out very weird issues. So when he performed the scaling test with some specific number of nodes, the performance efficiency dropped very quickly. So it's very weird. And then he tried to get the performance data in CRAYPAT, and this is a comparison between the 2 different cases. So using the Apprentice, you can also compare 2 different runs one by one. And you can also get some activity over time here. So he could also you can also zoom in and see what's going on in a specific time frame. And you can also compare what is the number of cores and number of time. So in this example, he realized, oh, here, so CG solver has a similar number of cores, but on the left case, time is much longer than the right cases, right? And then he just realized, okay, so CG has very MPI communication, so he wanna go into the MPI tracing. So he did the -G MPI, and then this is one of the results from -G MPI through the APP2. So this chart shows the communication pattern between the MPI's ranks. This is a destination, this is a source, and you see a lot of communication happen with the colors. And this is the case with the problematic efficiency. And when he tested a different number of nodes, he see this kind of well-structured MPI communication pattern. And then he realized, oh, with that specific number of nodes, for some reason, MPI communication is disrupted, and then the communication pattern become worse than the other cases. Is why that case lose the performance efficiency. And then he tried to find out the optimal MPI partitioning for that specific number of nodes. On the right-hand side, you see the optimal MPI partitioning. And then he could get better performance. So this is default MPI partitioning. You see in this example, for same number of nodes, same input, it spent 9,000 sampling for the MPI, but with optimal MPI partitioning, the sampling number is dropped to 4,700, something like that. So through this process, he could optimize that problematic one with optimal MPI partitioning and could get the better efficiency. So yeah, this is summary. I quickly will introduce the two modes to use the CRAYPAT-LITE mode in in-depth analysis, and also introduce the performance counter through the CRAYPAT and CRAYPAT API and Apprentice 2. And this is our AirStep CRAYPAT user guide. So at the beginning of this year, we restructured our user guide. And we added more content. So please visit our user guide, and if you miss something, just let us know. And also for more support, you can reach out to me or the AirStep Performance Engineering Group. So this is all I have today. If you have any question, please let me know. Thank you.